So now we'll consider rotation about a point P about this axis, and this axis is given by or represented by the unit vector v cap. So the initial position of P is this Pi, and Pi rotates about this axis by an angle theta and comes here, and the final position is Pf. So this is the position vector of the point P initially, Ri, and Rf is the position vector of point P at a later time, and delta R is the difference between these two position vectors. So as if this line is rotating about this axis, and from here, from this position, it is coming here. So now if you think of a rigid body, all the lines constituting the rigid body, including the axis small x, small y, and small z, can be considered to be rotating about this axis v cap. So now this triangle OPIPF, OPIPF, here we are drawing as if we are seeing from the top, and we are getting this triangle. And from PF we drop a perpendicular on OPI. Now we call this vector from PI to this point as from PI to this point, from PI to this point, from PI to this point as B1, and from here to here B2. So B1 plus B2 is equal to delta R. So delta R is B1 plus B2. Vector addition of B1 plus B2 is delta R. Now what is B2? The B2 has a magnitude and a direction. The magnitude of B2 is nothing but A sine theta, where A is the radius. This is A, and this is also A. So this A is the radius. So this vector has this vector B2, I missed this. This vector B2, yeah. This vector B2 has a magnitude of A sine theta. And what is the direction? The direction is from here to here, here to here. That is here to here. That means it is V cross R. V cross R. V cross Ri. V cross Ri is perpendicular to this plane OPI and this point of rotation OPI, this plane, and it is perpendicular to this plane. So this is perpendicular to this plane OPI, and the origin forms a plane, and perpendicular to this plane is this B2 vector. So unit vector along B2 is V cross Ri divided by magnitude of V cross Ri. So this is V, magnitude of V, Ri, and sine theta, not sine theta, this should be sine alpha, where alpha is the angle between this V and Ri. So this is sine alpha. So now Ri sine alpha is A, and the magnitude of V is 1 because V is an unit vector. So V is a unit vector. So this is Ri sin alpha. So Ri sin alpha is A. So this A and this A get cancelled out and it becomes sin theta V cross Ri. Now what is B1? B1 has a magnitude of A minus A cos theta. So B1 has a magnitude of A into 1 minus cos theta, and direction of this is, so this is the B2, this is perpendicular to B2. Perpendicular to B1 is from PI to this. So it is perpendicular to B2 and it can be given by V cross R. So V cross R. So V cross R is along B2. V cross R is along V2. So V cross R is along this. So V cross R is perpendicular to this plane, and if you take V cross R, V cross R, then that is actually along this line, because V cross R is B2 and V cross R, B2 is from here to here, V2 is from here to here or here to here. So V cross this is perpendicular to B2, perpendicular to both V and V cross R. V cross R, remember, V cross R is here to here, perpendicular from here to here, or sorry, from here to here is B2. So B2 is actually from here to here. Now V cross B2 is perpendicular to this. So along this, from PI to this foot of perpendicular. So this is V cross Ri and divided by magnitude of this. So V is a magnitude of 1 and V cross Ri, you know, the magnitude of A. So V cross Ri divided by A gets cancelled out, and so this is this. So this is 2 sin square theta by 2 V cross Ri. Now let us have a look at matrix representation of cross product. Let P equal to V cross Ri. That means P capital X capital I, P capital Y capital J, P capital Z K is a vector is equal to this Ij, cross product of V and Ri. So now if you expand it, I into this minus this into this minus J into this minus this into this plus K into this and this into this. Now Px is this, Px is this, Py is minus this, and Pz is this. That means if you write it in a matrix form, Px is minus Vz Riy minus Vz Riy plus Vy Riz. Okay. Then Py is minus Vz. So here I have made a mistake. That should be plus and this should be minus. This is plus Vz Rix minus Vx Riz, and this is Vx Riy minus Vz Rix. So okay, so all the terms are correct. So that means now these components can be written as this using this matrix notation. So P means P contains in a column the components of P along capital X, capital Y, capital Z, and Ri are the components of the Ri vector, the capital X component, capital Y component, capital Z component, and V has now become a matrix, a skew symmetric matrix. That means if this is minus Vz, this is plus Vz. The diagonal is 0. Whatever you are getting here at first row, third column, third row, first column will be minus of that. So Aij equal to minus Aji, and Aii, if I equal to j, then you get 0. So del r equal to b1 plus b2. So del r can be written in matrix in vector form as rx, ry, rz, del rx, del ry, del rz. This in b1 capital X, b1 capital Y, b1 capital Z. That means the components of v vector along capital X, capital Y, capital Z plus components of v vector b2 vector along capital X, capital Y, capital Z. Now this is Rf minus Ri. This contains the components of Rf and this contains the components of Ri, equal to sine theta Vr, because this B1 is sine theta V cross Ri. So in matrix form it is V cross Ri, and this is 2 sine square theta V V Ri. V V Ri, where V is this matrix. This is the V matrix. This is the V matrix. This is the V matrix. So this is the V matrix. And since the second term is V cross, so V cross Ri is Vri again V multiplied by V. So Rf equal to Ri plus this, or this means I identity matrix into Ri. Ri means Ri is same as I Ri. The same as this. So I plus sine this plus 2 sine square theta by sine theta this, 2 sine square theta by 2 this. So that means Rf is equal to this into Rf equal to this into Ri. So this R is again the rotation matrix. That means the coordinates of the final point or point at a later time along capital X, capital Y, capital Z equal to R multiplied the coordinates of initial coordinates of the point in capital X, capital Y, capital Z along capital X, capital Y, capital Z. So now this is the rotation matrix. Now this is the rotation matrix. This is the rotation matrix, and rotation matrix can be written like this. Rotation matrix can be written like this. So this is called the Rodriguez formula. Now if you just use this notation that cos theta by 2, theta is the angle of rotation, and you call it theta naught. Theta 1 is nu x is the capital X component of the unit vector nu, sine theta by 2, capital Y component of unit vector nu, and capital Z component of unit vector nu. So theta 1 is Vx sine theta by 2, theta 2 is Vy sine theta by 2, and theta 3 is V capital Z sine theta by 2. So that theta square plus theta 1 square plus theta 2 square plus theta 3 square is equal to cos square theta by 2 plus Vx square plus Vy square plus Vz square within bracket into sine square theta by 2. So Vx square plus Vy square plus Vz square equal to 1, because it is a unit vector. For unit vector, the square of x, y and z components, they add up to 1. So this is sine square theta by 2 plus cos square theta by 2. So theta naught square plus theta 1 square plus theta 2 square plus theta 3 square equal to 1, or 0 to 3 theta k square. K takes values from 0 1, 2, 3. Square equal to 1. So these are called the Euler parameters, and if you write the rotation matrix in terms of Euler parameters, it is something like this. Now what is trace of R? The trace of R is the sum of the diagonals. Oh sorry, not this one. The sum of the diagonals. Sum of the diagonals. So we have taken the sum of the diagonals. So 1, 2, 3, 3 minus 2, theta 2 square plus theta 3 square plus theta 1 square plus theta 3 square plus theta 1 square plus theta 2 square. So it is actually 4 theta 1 square plus theta 2 square plus theta 3 square. We add 1 4 theta naught square because this adds up to 1, and we again get 4 theta naught square plus here. So this is 1, so 3 minus 4 is minus 1 plus 2 into 2 theta naught square. And what is 2, what is theta naught? Theta naught is cos theta by, theta naught is cos theta by 2, so cos square theta by 2. So this is 2 into 2 cos square theta by 2, and you know 2 cos square theta by 2 is equal to cos theta plus 1. So this is 2 into cos theta plus 1. So 2 comes out, this becomes 1 plus 2 cos theta. So trace of R is 1 plus cos 2 theta. So if you have the rotation, if you know the rotation matrix, you can find the trace of it, and from the trace you can find the angle theta, and angle theta is the amount of rotation. So angle theta is the amount of rotation. So if you, this is the axis of rotation, this is the amount of rotation. This is the initial point, this is the final point or point at a later time. This is not required here. So let us stop here. So